Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for exam MLC. It's actually from the last exam MLC from fall 2017, multiple choice section, section, and problem number 10. For a special whole life insurance of $100,000 on a 40-year-old, you are given death benefit is payable at the moment of death. Level gross premiums are payable monthly for a maximum of 20 years. Mortality follows the illustrative life table. Interest rate is 6%. Deaths are uniformly distributed over each year of age. Initial expenses are $200. Renewal expenses are 4% of each premium, including the first. So not really renewal, but every year expenses are 4% of premium. Gross premiums are calculated using the equivalence principle. Calculate the monthly gross premium. One important observation is that the premium is paid monthly, but the benefit is paid continuously, so two different modes of payment. However, we are told that uniform distribution of deaths applies. Interest rate is 6%, and we can use the illustrative life table. So we can look up things in the table because the interest rate is 6%. In terms of actual present values of death benefit and so on. And using the uniform distribution of deaths assumption, we can switch from a continuous life insurance actual present value or single benefit premium to the fully discrete, which is in the table, and the monthly annuity could be switched to an annual annuity for which the actual present values are in the table. So let us write G for the monthly gross premium sought. By applying the equivalence principle, we obtain that, now it's monthly premium, so annual rate of premium is 12 times G. So 12 times G paid as a monthly annuity, but with the annual rate of premium 12G, just like the annual rate of payment for just unit annuity A double dot upper 12 is 1. It's on a 40-year-old, but only up to 20 years. That pays for $100,000 of death benefit paid upon the moment of death. That's why it's A bar 40 plus 200 single expense at time 0 plus 4% of all the premiums, which is the other expenses. Well, all the premiums are on the left-hand side, so it's just 4% of that. Now, G is the only unknown in this. The other ones we can figure out. So we solve it for G, and we get G to be equal to 100,000 times unit death benefit value plus 200 divided by 0.96 times 12 times A double dot upper 12 40 colon angle 20. When I see UDD assumption for the case of life annuities, my inclination is always to try to use the David Ricardo formula first. And it's very tempting, but in this case, actually, memorizing the UDD identity for life annuities is much more productive because we can just write out A double dot upper 12 40 colon angle 20 under UDD is alpha of 12 times A double dot 40 colon angle 20 minus beta of 12 times 1 minus 20E 40. Now, the reason why we subtract that is because the life insurance that corresponds to this life annuity would include the endowment part, but we don't account for it without effectively adding this component here. So this is the way you should memorize this formula. And alpha of 12 and beta of 12 are in the table given on the test. And then A double dot 40 colon angle 20 can be written as A double dot 40 minus 20E40 times A double dot 60. And now every single thing that you see there is in the table. So we looked them up in the illustrative life table. The alpha and beta are at the very end with the illustrative service table and some interest rate functions. And we plug all the numbers in and we get approximately 11.424704. Now remember, this is just the annuity that corresponds to how the premium is paid that we calculated here. We need to plug it into the formula for G in just a moment. But I'm going to try to use the David-Ricardo formula to show you that in this case it actually is harder to do it this way. So I think that David-Ricardo is your friend, always. And if I were to use the David-Ricardo formula, then I would write A double dot, upper 12, 40 colon angle 20 is 1 minus big A, upper 12, corresponding to a life insurance where the death benefit is paid at the end of the month of death, 40 colon angle 20, but it's an endowment insurance, because endowment corresponds to this annuity that we have, divided by D upper 12, because it's double dot, so it's D and upper 12, so it's D upper 12. Then we need to express D upper 12 in terms of the interest rate of 6%, which is going to be 12 times 1 minus 1.06 to a negative 1 over 12, while the endowment will be written as term insurance with a payment at the end of the month of death. That's why it's a 12 there, but it's also a term insurance, minus pure endowment. And under UDD, that life insurance now always has a simpler formula than life annuity. That's why we go to David-Ricardo for help. Can be written as 0.06, the interest rate, divided by I per 12 times a regular term insurance over those 20 years. And we need to figure out what I upper 12 is. So I upper 12 is going to be 12 times 1.06 to 112 minus 1. Then the term insurance needs to be rewritten as A40 minus 20E40 times A60. And now everything that we have here can be found in the table, so we plug it in. And we get, well, we get a slightly different answer. It's 11.424804, and before we got 11.424704. Well, unilaterally, in this case, I'm declaring that David-Ricardo is more complicated. Is the more complicated approach in finding the value of this annuity. A double dot upper 12, 40 colon angle 20. Maybe you don't feel this way. Whichever way you calculate it, you need to calculate that annuity. We have it. I'm going to use the first value that we found, not this one. It makes almost no difference in terms of the answer. So we just find the value of G using the first approximation. We plug in all the numbers. And of course, A bar 40 is written as I over delta times A40. I over delta is in the table, and for 6%, of course, and A40 with interest rate of 6% is in the table. So we plug it all in and we get 126.97328. That's answer C. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries, but the solution is mine. Good luck in your studies and good luck on the test.